It's another math day here with teacher Jenny. So join me for another discussion, and this time we're discussing sampling distribution and what is or how to do sampling distribution. So when you say sampling distribution, everyone, this is the probability distribution when all possible samples of size n are repeatedly drawn from a population. As we all know, we have a lot of distribution tackled here in statistics. We have probability distribution and we have normal distribution as well, in which every distribution there talks about probability. So same thing here, we are also talking about probability or the possibility or the chances of you choosing this combination of sample which has your sample mean on it. Okay, so let's get to the topic. We have here an example in which we are going to construct a sampling distribution of the mean for the set of data below. We have our 86, 89, 92, 95, and 98. So more likely this is your population. Okay, now, and these values are probably, let's say for example, these are now the grades of a student of how many are they? We have 1, 2, 3, 4, 5. We have 5 students as taken as population in here. So how to construct our sampling distribution? So first, we have our solving for the population mean. Now, why do we need to solve for the population mean? We wanted to estimate our mean for the entire population here in a way that later on, once we do our distribution, that sample mean or the mean or the sample or the mean of the sample, the mean of the sample there will be more likely concentrated or distributed between that value, which is our population mean. So let's try to calculate our population mean. How to calculate? This is more likely similar to you getting the average of that grade or that value. So we have that one as mu. This is now the symbol for your population mean. I guess I was able to discuss this one among my section that your symbol mu, this is for the population mean, because later on we'll be talking about the different types of mean. We have population mean and we have the sample mean. So for the population mean, we can get that one by simply having the summation of x divided by your n, where your summation of x now these are the values that you've got for your population, or the values for each of the member of the population. And your n there is the number of the population, or simply the population size on it. So more likely you're just getting the average. So we have here 86. Let me change my ink. We have our 86 and then we have our 89. So we're simply adding that one because we have our summation. So adding our 89, next value is 92, and next value is 95, and next one is 98. And we're dividing that one with our number of values in there, or our population size. So we have 1, 2, 3, 4, and 5. So we have 5 values there, and this is how we get our population mean. So adding, we have 86 plus 89 plus 92 plus 95 plus 98. We divide that one with your population size, which is 5. That will be equal to 92. So our population mean here, that will be equal to 92, or this is simply our average. Okay. Okay, step number 2 here is to construct all random samples consisting of 3 observations. We have n equal to 3 from the given data set. Arrange the observations in ascending order without replacement and repetition. Then get the sample mean of each random sample. So how do we do our step number 2? There's a lot of words in there. Now, normally when you say number of observations, you as the researcher will be the one to set that up. So if you wanted to have 2 observations, then you have there n equal to 2. Or the n there, the small letter n, that signifies the sample. So if you wanted to choose only 2 samples randomly, then you will have your n equal to 2. But this time, let's have our example. We stick to the example there that our n here, or the sample size here, is equal to 3. So how do we do that one? Since we are doing this one randomly, meaning to say each of your value in there will have an equal chances because we have that one as randomly selecting the samples in there. So how to do that? Okay, we're doing step number 2. So step number 2 is for us to construct a sampling distribution. We are going to get the possible combinations of your sample, wherein your sample is or the sample size is equal to 3 based on what the researcher is setting. So let's have that one here. How to choose our samples is simply starting with our first number. This time we are going to have no repetition on our combination for the sample in here. And we are arranging this one in an increasing order. So we'll start with 86. So from 86, you can choose the next number as 89. And the next number will be 92. So that's one possibility. And another possibility could be, since we still have more than that one possibility in there for that combination, we have next combination would be starting from 86. We go down to the next number, which is 89. Notice we end with 92 on the other combination. So next number will be with the 95 until you have your 98 in there. So next number or next combination, we have 86 and then 89. And then we go to the next number to your 95, which is 98. So that's your possible combination for 86 and 89. Now, we don't have any other number after 98, so we stop that combination. We go for next one. We still have 86. And the next one right after 89 is we have 92. So we will be writing 92 in there. And we go for the next value, which is 95. And still, we still have another number, which is 98. So we repeat the first 2 digits, which is 86 and 92. And make use of the last number there, which is 98. And that's the end. Next possible combination is still 86 because we paired 86 with 89 and 92 already. We can still have 3 more numbers or 3 more samples if we do 86 because we can have the 95 on it and the 98. So combination, possible combination will be 86, 95, and then 98. So more likely we are doing it by 3s. So the next one, we go for, since we're done with everything under 86, so we go to the next number. We start with 89. And your 86 now is not part of it because if you try to write 86 again, take note we're arranging this one in an increasing order. That means we will be starting off with another 86 and that will be repeated. Right? So we start with 89. 86 is out already. So we have 89. And the next number to it is 92. Next number will be 95. And that's it. That's one more combination. Next, we go to the other combination. We've utilized our 92 with a pairing of 95. But still, we have another number in here. That means to say we can make use of our 89 again and the 92. And we pair that to another number, which is 98. So that's the last number in there. Next one, we have 89 paired to 92 a while ago. So that means we go for the next one. We have 89 and 95. And we can get one more combination out from 89 and 95. And that by pairing it or adding 98 on it as the third number or value. And lastly, we're done with the 89, so we move to the next number, which is 92. So we have 92 that can be with the 95 and then the 98. Now, notice if you go for 95, you cannot create a 3 value in there or a 3 sample. So we don't have any other combination. That's the end of the combination in there. So I hope you were able to follow through. If not, I will be making another video with another example so that if you were not able to catch up with this one, then go to part 2 for another example. Okay, now next, we're done with this one. We're done with the arrangement of your combination or possible combination for the random sample there. So this would simply mean that when you choose a sample, you could either have 86, 89, 92, 86, 89, 95, 86, 89, 98, 86, 92, 95, and so on. So that is the case here so that you can picture it out what's going on. Now, next, once you have your possible combination of the different samples with a sample size equal to 3, then you are going to get the sample mean. How to get the sample mean? By the way, the symbol for the sample mean is with the X in there and with a bar at the top. That is your symbol for the sample mean. Now, what is the sample mean? This is now the average of your sample values, okay, or the values of your sample. So let's say the first combination, we have 86, 89, and 92. Once you wanted to get your sample mean, you just have to get the average literally, meaning to say you add all 3 numbers and divide that one with number 3. So that's how you get your sample mean. So let's now compute for the sample mean, everyone. So let's start with our 86, 89, and 92. So adding that one, let me just have that one somewhere here. 86 plus 89 plus 92. We divide that by 3 because there are 3 values of your sample in there. So we have 86 plus 89 plus 92. We divide that one with 3. By the way, sorry. So that is equal to 89. So the sample mean here is 89. Next, we go for the next possible sample. We have to get the mean in there, 86 plus 89 plus 95 divided by 3 in there. So we will be repeating the process for the entire sample, combination of samples or samples in there or values of the samples. Sorry. Okay, 86 plus 89 plus 95. We divide that one with 3. That is equal to 90. So this is now your sample mean for that sample. Next, we're adding our 86 plus 89 plus 98. We divide 3 on those values. So computing that one, that will be equal to 91. Next one, we have 86 plus 92 plus 95. We divide that out with 3. So this is equal to 91. Next one, we go for 86 plus 92 plus 98. We divide that out with 3. That will be equal to 92. Next one, we have our 86 plus 95 plus 98. We divide this one with 3, and that will be equal to 93. That will be your sample mean for that one. So next one, we have our 89 plus 92 plus 95. We divide that one with 3, and that will be equal to 92. And next, we have 89 plus 92 plus 98. We divide that one with 3, and that will be equal to 93. Next one, we have our 89 plus 95 plus 98. We divide this out with 3 in there, and that will be equal to 94. And lastly, we have our 92 plus 95 plus 98. We divide this out with 3. This is equal to 95 as your sample mean. So that's how you are going to do it. Now, that is step number 2. For step number 3, this will be our step number 3. We are going to... So here is now our step number 3. We are to construct the sample distribution of the sample means. So this time, in constructing your sample distribution, we are going to base our values on the previous steps. So once we have our sample mean and the combination of your random sample, we are now ready to do our sample distribution. So doing this one, we are going to write our sample mean. So all the values here found on this column, we are going to transfer that out in there. So we have our least value, or the smallest value for our sample mean is 89. And then we have 90 also. So again, you do not write the repeated value of your sample mean. We only have to have the unique value. So next one, we have 91, and we have 92, and then we have 93, and then we have 94, and lastly, we have 95. So that will be your sample mean. Now, in getting the probability in there for the sample mean is for you to know how many samples have 89 as their sample mean. Or literally, you are basing your answer on the probability in there on the previous table. So you will be counting how many are those 89 found on that table. So here, we only have 189. So that means to say this is 1 out of how many possible combinations that we have there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1 out of 10, or this is simply equal to 0.1. So that is how you are going to get your probability. Next one, we go for 90. We count how many are those with the 90 as a sample mean. We only have 1. So again, this is 1 out of 10 possible combinations of your sample mean, and we have that one equivalent to 0.1 or 0.1. Next, we go for 91. We count how many are those with 91. We have 1, 2. So there are 2 out of 10, or that is equal to 0.2. Next, we go for 92. We count how many are those with 92. We have 1, 2. That will be 2 out of 10. And this one will be equal to 0.2. Next, we go for 93. 93 in there, we have this 1 and 2. So we have that as And that will be again 2 out of 10. So this will be 2 over 10. That is equal to 0.2. Now for 94, we only have 1. So this is 1 out of 10, or this is equal to 0.1. And lastly, we have our 95, which is only 1. So we have 1 out of 10, or this is equal to zero point 0.1. Okay, now going back on the sample mean, by the way, now I've mentioned at the very start that when you say population mean, your distribution of your sample mean will be around that population mean. So if you've noticed, our distribution of your sample mean, we have 89 up to 95, and our population mean a while ago is 92. So it's more likely it's found in between those values. Okay? So moving on, so we have this now as our probability distribution. So we have 89 with 0.1, 90 with 0.1 chance, and a 91 with 0.2, 92 with 0.2, 93 with 0.2, 94 with 0.1, and 95 with 0.1. So that will be your sampling distribution. Now, let's try to have a clearer picture here by simply doing our histogram. An histogram, by the way, is somewhat like similar to your bar graph. This is now a way for us to present our distribution in a clearer picture. So we are graphing. So let me just change the color. Okay, there. Now our sample mean, so we will be placing that one in our horizontal axis, your sample mean, and this is now your symbol. So our sample mean ranges from 89, we have 89, we have 90, we have 91, 92, 93, 94, and we still have 95. Sorry, I'll be extending this one. Okay, now next, on the 89 there, we have that one as 0.1. Take note, on our distribution a while ago, we have two probabilities as repeated result. We have 0.1, so I can have it like here, my 0.1. And this can be my 0.2. We have only 0.1 and 0.2 a while ago. So graphing that one under 89, we have that as 0.1, or with the probability of 0.1. So I can just simply draw a rectangle for my 89 in there with the probability as 0.1. So let me just name it as P of X bar, or that will be the probability of your sample mean. Next, we go for 90. For that 90, we have our probability as 0.1 again. So I can draw another rectangle. Sorry, I'm not that good of an artist. Okay, I'm not gifted on that field. Anyways, so assuming that that's perfectly a rectangle, so that will be your graph. Next one, we have our 91, and 91 will be with 0.2. So again, I can draw another rectangle here for my 91. And then next one, we have our 92 with the probability of 0.2 again. So I can just draw it like this. Next, we have our 93 with 0.2 as the probability a while ago. We have it like this as well. And lastly, the two values for the sample mean, we have 94 and 95. They both have 0.1 as a probability in there. So I can just draw it like this one. So this is now how you draw your histogram on the sampling distribution that we had. So if you try to look at that one, they are more likely normally distributed at the center of your 92, which was a while ago. We've computed that one as this is our sample mean, right? This is our sample mean, the 92. So I've mentioned that your sample mean there will be around that value, which is 92. So that is how you do your sampling distribution. Again, if you were not able to follow, then kindly look for my second part of the video for another example so that you can follow through. And I suggest you have to practice on your own so that you will be guided along the way. And again, nothing in math is really difficult. It's a matter of your hard work and how you try your best to work on with different problems in math. So again, this is your teacher Jenny signing off. And please like, share, and subscribe to my YouTube channel for more videos. And kindly click on the bell icon so that you will be updated for my next video. Goodbye.